That's fine. I'll pick one. So let's look at 41. So the sine of x is equal to square root 3 minus sine of x. So our goal is to isolate the trig function, and then we have to use the unit circle. So since I have two sines, I'm going to add sine of x to the other side. So now I have 2 sine x is equal to square root 3. And then what do I have to do next? So we divide both sides by 2. So sine of x is equal to square root 3 over 2. Sine tells me I have to look at what value on my unit circle? The y value. So I have to see where my y value is square root 3 over 2. So that would be 2 pi over 3. So x is going to be equal to 2 pi over 3 and pi over 3. So these would be my two answers. All right, so looking at the second section, so I'm going to do number 53. So we have cosine squared x plus sine of x is equal to 1. So what do I do if I have a cosine and a sine in the same problem? I have to change cosine to be sine, so I have to use one of my identities. So the identity I'll use will be cosine squared plus sine squared equals 1. So I'm going to replace that cosine squared, so I want to find out what cosine squared is equal to. So if I move the sine squared over, I know cosine squared is going to be equal to 1 minus sine squared. So I'm going to take this 1 minus sine squared and replace the cosine squared with it. So 1 minus sine squared x plus sine x is equal to 1. Next, I want to combine like terms. So what could I do? Can I add the signs together? No, because one's a sine squared and the other one's just sine.
You're going to set it equal to 0 and factor.
I'm going to set it equal to 0 and factor. So I'm going to move the 1 to the other side. It'll end up canceling out, so I just have negative sine squared x plus sine of x is equal to 0. How would I factor this? I could take out the negative, so that would work. So just divide everything by -1. So sine squared x. You don't have to, but it doesn't change anything. Bless you.
Oh, pull out a sign maybe?
So usually we'll see this where we have like an x squared plus x plus a number. And then we would say, what are our two factors of this to add to the middle one? But here we don't have that number. I do have a greatest common factor, though, that I can take out, which is sine. So I'm going to take out a sine, and then I'm left with sine of x minus 1. And then from here, I can just set both of these equal to 0. So sine of x equals 0, and sine x minus 1 equals 0. So the first one's already solved. Sine tells me I have to look for the y value on my unit circle. So I have to see where my y value is 0. So that'll be at 0 and pi. For the second one, I have to solve for sine of x. I have to isolate that trig function, so I'm going to add 1 to both sides. So sine of x is equal to 1. So here I have to look for where my y value is 1. And that would be pi over 2. And that's it. So these would be my 3 answers. All right, we're going to do one more of the multiple angles one. So we'll do a tangent. So let's do 56. So that is square root 3 times tangent of 3x is equal to 0. So again, step 1 is I want to isolate that trig function. So I'm going to have to divide by square root 3. So tangent of 3x is equal to 0 divided by square root 3 is just 0. I can't touch inside here yet. I just have to find what the tangent of 0 is. So tangent tells me I look at what value on the unit circle? Y over x. So I have to see where my y over x is 0. So pretty much I just need to know where my y is 0, because if it was 0 on top of the fraction, the whole fraction is 0. So y would be 0 at 0. So I have 3x is equal to 0, and 3x is equal to 5. And I wrote 3x because I have this 3x here with the tangent. And what's the last step? Divide by 3. So I have x is equal to 0 divided by 3 is just 0, and then pi divided by 3 would be pi over 3. So if you have a multiple angle, if you have anything happening directly to that x, you do the same exact thing. That's just the last step. So there's just one additional step at the end, but everything else you do the same from before. All right, so we're moving on to the right side of the page. So for 71 through 74, we just have to write the expression as sine, cosine, or tangent. So we're not actually having to solve here. So we want to see which one of these equations, so like here I have sine times cosine plus cosine times sine. So that would match up with my first identity, which would be sine of a plus b. So here our a is 130 and b is 50. So it'd be sine of 180. And that's all we have to do. We could actually find what the sine of 180 is. We just look for a y value at 180, which would be 0. But here we just have to write it as sine. So if I did 73, a tangent one, I have tangent where I'm adding on top. So that would go with this equation here. So that is tangent of a plus b. So my a would be 25 and my b is 50. So I just take the two numbers that are given in the equation that's given. So this would be tangent of 75. All right, let's look at one of the ones from the bottom. So we could do 79. Do a cosine one. Yeah, because for these, it's just asking for the sine, cosine, or tangent. So you don't even have to evaluate. You can just leave it like that. Right, for 79, we have to find the exact value of the trig function given that sine of u is 4 over 5 and cosine of v is negative 7 over 25. Both u and v are in quadrant 2. So I have the cosine and I'm adding one. So that is going to be this equation here. So instead of a's and b's, I'm just using u and v. So I have cosine of u times cosine of v minus sine of u times sine of v. So I have two different triangles here. I have my sine triangle and I have my u triangle and my v triangle. So first it gives me sine of u, which is 4 over 5. So for my u triangle, sine is what over what? Technically, yes, but in terms of x, y, and r. Y over r. So this would be y, and this one would be r, because it's y over r. So in my triangle, it says I'm in the second quadrant, which would be this one over here. My y is 4, and my r is 5. So how would I find the x? Pythagorean theorem. So I have 4 squared plus x squared equals r squared, which r is 5, so 5 squared.
Wasn't there like another formula where they make you do r is equal to square root of x squared plus, or a squared plus b squared?
So this would be 16 plus x squared is equal to 25. Subtract 16. So x squared would be 9, so x is 3. How do I know if it's a positive 3 or a negative 3? It's on the left, so it would be a negative 3. So I'm going to write it here. Negative 3 is x. So that's my U triangle. This is U. Now I need to do the same thing for my V triangle, which it gives me that cosine of V is negative 7 over 25. Cosine is what over what? In terms of x, y, and r. X over r. How do I know where the negative goes? Does it go with the x or does it go with the r? It goes with the x because r is never negative. So I have a negative 7x and 25r. So if I draw my triangle, again, it says it's in the second quadrant, so it's over here. X is negative 7, r is 25. So I have to find y. How do I find y? Pythagorean theorem. So I have negative 7 squared plus y squared is equal to 25 squared. So 49 plus y squared is equal to 625. Minus 49. Just take the square root of that. That would be 24. So y is 24. Is it going to be a positive 24 or negative 24? Positive, because it goes up. So y is 24. So this is my x, y, and r for my V triangle. So now I go back to this formula that I had here. Cosine would be what over what? Cosine would be x over r. Again, here I have x over r. And sine would be y over r and y over r. So cosine of u tells me I have to look at the first triangle here, my U triangle. So I would just take the x, which would be negative 3, over the r, which is 5. Next, I have cosine of v, so I move on to the second triangle down here. So x is negative 7 over r, which is 25. Minus sine of u. So use my top triangle. Sine is y over r, so that would be 4 over 5. Times sine of u, which is my bottom triangle, so that would be 24 over 25. And then we just multiply and subtract. So here I'd have 21 over 125 minus 4 times 24. Which would be 96 over 125. So 21 minus 96 would be negative 75 over 125. Remember, this final is multiple choice, so your answers will be simplified. So it'll be negative 3 over 5 as our answer. Yes. So this is our answer. So here we have law of sines and Heron's area theorem. So these we want to use the formulas for. All right, so we can start with number 1. they're all pretty much the same, just different numbers. So we always want to start with a pair. So I have A, angle A and side A. So I can do the sine of angle A over side A is equal to the sine of angle B, which I was given B also, so that would be 50, over side B. And then we solve. So you can cross multiply. And you can do this a bunch of different ways. You can evaluate the first fraction first and then cross multiply. I'm going to cross multiply first. So I have B times sine of 32 is equal to 16 times sine of 50. And then I'm going to divide by sine of 32. So then B is just going to be whatever this is in the calculator. So we should get 23.129, so I'll say 13. And this would be, it doesn't give us any units, so we can just leave it like that. So that's side B. How can I find angle C? If it gives me two sides of the triangle, how do I find the third? You can't do Pythagorean theorem here because it's not a right triangle. But how do I find the third angle? What do all three angles have to add up to? 180. So I would just do 180 minus the 2 that I was given. So 32 plus 50 would be 82. So 180 minus 82 would be 98. So angle C is 98 degrees. Now I can use that to find side C. I'm going to keep my same proportion. So I have sine of A over side A is equal to sine of C over side C. I'm going to cross multiply. So I have C times sine of 32 is equal to 16 times sine of 98. I'm going to divide by sine of 32 on both sides. So C is equal to whatever this is in the calculator. So that gives us 29.899, so it would be 90. Again, multiple choice, you don't have to worry about adding. Really don't even have to worry about the units because those will be on there already for you. Just coming up with the numbers is the important part. Number 11 and 12 were done for you guys. The answers were already on there, but it's important to know how to do it. So our equation for the area of a triangle is 1/2 B times C times sine of A. So always it'll be whatever angle you're given times the two sides times 1/2. Again, these equations are given for you. So this is area. So we would just plug it into our calculator like they did here. They got 19.06. For 21 and 22, we actually have to use law of cosines because it only gives us side lengths. So when only side lengths are given, we have to use law of cosine. So our law of cosine would be, always start with the biggest angle. So here I'm going to start with 16. So I'll have cosine C is equal to A squared plus B squared minus C squared over 2AB. Yes. So we just plug in everything we have. So cosine C is equal to 6.5 squared plus 10.2 squared minus 16 squared over 2 times 6.5 times 10.2. So we put the whole right side into our calculator. So when I put that in the calculator, I get negative 0.8273. This is just the cosine of C, so then to find what the actual angle C is, we have to do the inverse. So you would do that cosine -1 of this number, so negative 0.8273. So take the inverse cosine of that, and we'll get angle C is 145.83 degrees. So that's just one of the angles. I still have to find angle A and angle B. How could I find another angle next?
Did you do what we did last? Use angle C, or the sine of C over angle C?
Yes, we would do law of sines next just because it's a little bit easier. So sine of the angle, so sine of 145 over, that was the angle C, so we have to do side C is equal to sine, I'm going to find the smallest one next, so sine of A over A is 6.5. Yes.
Do you have to find the smallest?
So we'll cross multiply sine of 145.83 times 6.5 divided by 16. So I got sine of A is equal to 0.2281. And then to find what actual angle A is, I have to find the inverse sine. So sine -1 of this. So that gives me angle A is 13.19. So I have A and I have C. How can I find B now? What do all three angles have to add up to? They all add up to 180, so I'll just do 180 minus 145.83 minus 13.19. So that'll give me 20.98, and that is angle B, the last one. So those are all three angles. All right, let's look at 27. So here we have to find the area again. It says use Heron's formula. So again, that one will be given to you as well. So Heron's formula is the area is equal to the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2. So to find S here, it would be 3 plus 6 plus 8 divided by 2. So I'm doing number 27. 3 plus 6 plus 8 divided by 2 would be 8.5. So I'm going to plug that into my formula here. So I have 8.5 times 8.5 minus 3 times 8.5 minus 6 times 8.5 minus 8. So this would be the square root of 58.4375. Just take the square root. So the area is 7.64. So we'll do 38. So it asks us to find, I guess we could just find B, C, and D because A got cut off. So we have to subtract the vectors, multiply by a scalar, and then multiply and add. So for 38, I'll do B first. So to subtract U minus V, we subtract the first minus the first, second minus the second. So it'll be 1 minus 3, which is -2. And -8 minus 2, so that turns into plus, which would be -6. For C, we're just multiplying U by 3, so it'll be 3 times 1 comma -8. So that would give us 3, -24. And then for D, we have to multiply by a scalar and add them. So it's 2 times V now, so it'll be 3, -2, plus 5 times U. So this will be 6, -4, plus 5, -40. And then we add them, so 11, -44. Alright, for 62, we have to find the dot product of U and V. So the dot product is the first times the first plus the second times the second. The dot product, your answer will be just a number. So first times the first, it'll be 7 times 4, which is 28. Plus the second times the second, so 12 times 14. 12 times -14. So 168. So 28 minus 168 would be -140. Second times the second. Okay, so let's do 67. Actually, let's do 68. So first it asked me to find the dot product of U and V, so that'll be the first times the first. So that is -3 times 2, which is -6. Plus the second times the second. So -4 times 1 would be -4. So when we add these together, we get -10. And then -10 times vector U, which would be -3, -4. So we just have to distribute that -10 to both the numbers on the inside. So this would be 30, 40. Let's do number 70. This will be the last one for today. So here we have to find the angle theta between the vectors. So this is another one of our formulas. So our formula for the angle between the vectors is cosine theta is equal to the dot product, so U dot V over the magnitude of U times the magnitude of V. So first we have to take the dot product. So that is the first times the first. So that would be 12. Plus the second times the second. So 12 plus 5, which would be 17. So our dot product is 17. Then we want to find the magnitude of U. So the magnitude is the square root of the first number squared plus the second number squared. So this would be 9 plus 1, so the square root of 10. You can leave it as the square root of 10. You don't have to simplify because you're just going to put it in the calculator. And then I want to find the magnitude of v, which is the square root of the first number squared plus the second number squared. So square root of 16 plus 25, which would be the square root of 41. So we want to put this in the calculator. So we get cosine theta is equal to 0.83957. Then how would I find what theta is? Just theta. Do what? So I find the inverse of cosine. So it'll be that cosine -1 button of 0.83957, which we'll get theta is equal to 32.9 degrees.